Well, as you can tell, I've decided to get this engine all back together. And these are the cylinder heads. And if given what happened, this is just awesome, because all my valves came out. You can obviously see that's bent. That one's okay, that one's bent. Doesn't matter, I'm gonna put all new valves in it anyways. But for everything to come out unbroken after breaking every single connecting rod in this thing at 8,500 RPM, which is normal, that is the normal RPM for it, not over rev. This thing is just great. So I mean, we just took this all apart. Every valve guide is fine, which is amazing. But I do have this super sturdy stout right there, exhaust guide. I explained that in the SML video, and I've explained that in the SMX videos also, about that valve guide that I've designed and worked on for the exhaust on this. And then these, these heads have 900 some odd miles, 40 some odd passes, one devastatingly broken set of connecting rods, and it looks like $1 million. So super happy with that. We're just gonna clean these all up, put new valves in it. Bada bing, bada boom. Ready to rock and roll. Alrighty, so you guys strong-armed me, pressured me into putting this back up into the machine and just remachining all of this. This is a engineering error. Not long story short, don't worry about this. But you can see, just had to rock recut all this. This thing actually ends up taking me probably another, well, I'm about 2 days behind, because you don't just put a block in the machine, hit the green button, and it just starts cutting it. There's a lot more entailed in that, so it's pretty complicated. But you can see, except for that one bolt hole. Now this one bolt hole is right there because this is moved out a little bit, and we put an insert in order to fix it. Well, the insert's bigger than what the material was, and ultimately there was a half a missing boss here originally. So not a big deal. Like that. And then you can see on the inside, now there's some spots I just can't and not gonna bother to fill, because it looks like this from the outside, and really don't care what it looks like on the inside as long as it's correct. So that is a repaired block. Now we're going to put the sleeves in right now. A lot of people question, why is there this gap in here? I explained that in these videos to you before, or if you go back and watch the video, a lot of times it'd be most all questions that people ask, I've already answered in previous videos. So, but this is the way the sleeve is designed. It's designed to be thicker up here. That's why you see this extra counter board there. This flat is here because we put a flat in there. It keeps things nice. We don't need a full round out here. There's flats here. So that way, every sleeve is exactly the same. If I had this round, I'd have to have a special sleeve just for the outside holes, and then different sleeves for the inside holes, because they need to match up. They need to mate here in the middle, okay? This is all to give it strength for the sleeve, for the cylinder pressure, because it's bigger, thicker right here. This is all steel right in this area, and then thicker material out here where the primary cylinder pressure is. Then here, so you can see down, we're gonna just go down, and I showed you the welding. We're gonna go down and just touch this up just a little bit more, and to get it so the sleeves will just slide right in like normal. The underside, you can kind of see here, so we remachined all this up. This one has got a little bit of material I didn't weld in, didn't care. So there's some little spots that just would only be cosmetic. There's no point wasting all my time for something that is totally cosmetic on the inside of the motor on my own personal stuff. So we'll be finishing up these bores, putting the sleeves in, and I'll show you all that. Oh, I thought I'd show you the other side. So this is the other side of the block. This one I didn't even bother recutting the outside because it didn't do any, not even cosmetic damage to it right through here. So that's all good. And then again, back over on the other side, all recut. Super pretty. All right, so what we're doing here, excuse me, what I'm doing here, so we froze the sleeves and we warmed up the block, and so that makes it so the sleeves just drop right in. Yeah, it makes it so the sleeves pull right out when they're not all destroyed. So now I'm just verifying how far up the sleeve is sticking above the deck surface. In my little ideal world, I'd like to see it about 3/1000ths above deck surface. So the sleeve actually sticks up, gasket comes down, the SMX hoop comes down, impregnates into the gasket, into the receiver groove below, pushes on the sleeve, but the sleeve is sticking up, which also helps kind of like emboss itself into the copper gasket. You know you're not in time lapse right now? Yeah, no, that's right. I was just letting everything go, so thank you, Kyle. All right, so we are in between 9 and 4 out. So this one over here is 4. I'm not sure, they really shouldn't do that. So, but I didn't verify these sleeve thicknesses before I put them in. I probably need to do that next time. And so what we're gonna do is we're gonna do a haircut, and we're gonna have to probably retouch up my, because I really want it 3. I'll go 3 to 5. 5 is about as much as I want. So we'll go down to 4 to where it's touching all the way across. Okay, for all you guys that giving me lots of input, which a lot of it was good input, but a lot of input on how to pull those sleeves out of this block when it was all damaged. I already have, this is the way we normally always do it, okay? I actually have this. This is old, beat up, because I use this all the time. In fact, this tool is specifically made for the SMX block. And you'll see here, now, I've warmed this block up a little bit, and the sleeves just come out like that. That is the normal way this whole deal works. Thought you'd like to see that. So what it is, we put these sleeves in there. I didn't like what they were, the heights of them. So what I'm going to do is we're pulling all the sleeves back out. Like I said, this is the way it normally works. Unless this is so destroyed at the bottom, I cannot pull it out. I have to machine them out. Okay, so anyways, we're just gonna pull this out. I'm gonna deck this block, or actually have Brock deck this block, and then we'll put the sleeves back in and then deck the top of the sleeves. Alrighty, sleeves in. Let's roll this over. Decked, sleeves in. Touch off the sleeves. We gotta just take them down and make them all equal. But we just did a cleanup cut on here. That way it can go in, still get my exact 3 to 4 thousandths. Actually, I think I'm gonna split the difference, go right at 4. Because like I said, I'd like to go anywhere between 3 thousandths and 5 thousandths high. So I think I'm gonna go right at 4. So we can do that here. And you can see this thing is sweet. All like new. No more windows, no more damage. Looking good. We're gonna throw this in the hone and rock and roll. But first, the mesmerizing 4th axis of blocks spinning. Gotta appreciate that. There we go. All right, so we've taken the block, SMX block, the wagon block, out of the big CNC machine, out of the 5-axis centroid, and now I have put it in to just double check, even though like I do a real explanation of, we've all recut this whole thing here. This, had been all blowed right out. So welded it up and remachined inside. And even though these rails are not part of the cap, I still wanted to verify that the line hone was straight, that nothing was moved, nothing was hit, nothing was destroyed. So what we do is we actually use a layout die in all of the journals and just very quickly run the line hone through, and then can look and see that it makes equal contact all the way around, or at least it makes a correct contact in the block side. So you can see there that it is making good contact on all the block side. Cap sometimes will move around just a little bit, so I think we might just tighten this up just a tick. We're going to put the main bearings in, check our bearing clearance while we have it in the machine, so we can just go right after that if I need to change anything. So that's a line hone. That is a line hone mandrel for all you guys that don't know. So this stone is, it's about 3 foot long or so, and goes directly through. We've already done the cam tunnel, and now we're doing the main tunnel, just to verify that it is correct. Cam tunnel is great, main tunnel is correct, looks good, but this is straight, and this is how you final size things to keep things in line. Hence oops, a line hone. you.